Okay, we're going to expand this expression, which means we're going to multiply these terms by x and these terms by 2. Grouping like terms. Once again. Same thing here. The two terms in the middle are going to add up to 0, so we're going to get x squared minus 49. You might recognize that as a difference of squares, and this as a perfect square. So we're going to multiply the two binomials, and then we'll multiply by the 3. So this is 7 times 3, and then 3 times negative 8, negative 24. So we're going to do the reverse process here. Thinking about how we expand the product of two binomials, which is what we just did. And so we need two numbers to multiply to 6 that add to 5. And if we expand this on the side as a check, we can check our answer to see if it is in fact correct. X squared plus 3x plus 2x plus 6 gives us x squared plus 5x plus 6, which is what we started with, and so we know we factored it correctly. So two numbers multiply to 6, add to 7. You can do the check on the side if you're feeling a little bit unsure. So we've got a negative number. So one of them has to be negative, one has to be positive. They add up to positive 1. That's how I know it's positive 3 and negative 2. In this case, the 3 is the negative, and 2 is positive. So we see multiples of 5 on our terms. We're going to factor out that 5 first. And then we know what to do. I see a negative coefficient on my x squared term, so I'm going to factor out a negative 3, not just a 3. Okay, so we've got two rational expressions. We're going to multiply them. And before we do the multiplying part, I'm going to factor the trinomial that I see here because there could be an opportunity to simplify my expression. So if I factor this, I'm going to have, oops, sorry, it should be a negative. And I see an x plus 1 term in the numerator and in the denominator. So if I divide the numerator by x plus 1 and the denominator by x plus 1, I get a simpler expression. And it's very handy to use this sort of crossing off method to keep track of where you are, so that you know there's 1 over x minus 3. And then we can do the multiplication, and we have a simplified expression. You might expand the denominator, but I'm going to leave it like this. Okay, we're going to do the same first step, and that is to factor any trinomials that we have. And so we see that we can factor out these factors. We can divide these factors out, and we're left with x plus 2 over x minus 3 times x plus 5. Okay, begin factoring. And so, because we know all the numerators are all going to be multiplied together, and the denominators are going to be all multiplied together, we can take a factor from the numerator of this rational expression and a factor from the denominator of this rational expression, and simplify by dividing them both out. And then we have this as our simplified expression. We have two trinomials. We're going to factor both of them. And just like before, we can pick out factors, pairs of factors that are in the numerator and denominator. And then we're left with this expression. Here we're doing division. And I've factored. And I see potential to simplify. And that's my simplified expression. So I've factored and I've written the rational expression I'm dividing by as multiplying by its reciprocal. And so now I can simplify. There's a few ways I could do it, but I'm going to take this pair of factors and this pair of factors, and I'm going to be left with this as my final simplified expression.